Hello everyone, welcome to another amazing session on problem solving. Well, everybody can benefit from having good problem solving skills, as we all encounter problems on daily basis. Some of the problems are obviously more severe or complex than others. It would be wonderful to have the ability to solve all problems efficiently and in a timely fashion without difficulty. Unfortunately, there is no one way in which all problems can be solved. Well, if you have a good problem solving ability, it can make a huge difference to your career. Let us start with today's session and explore what are the various problem solving techniques we can use to solve the given problems and improve on our problem solving abilities. Well, my name is Rajan Chetri. I'm the instructor for this session, and in today's session, I'm going to tell you the secrets on problem solving. So first of all, let us understand the roadmap through which we'll be covering this whole session. So in today's session, it's all about problem solving and understanding the problem solving processes. Now there are various techniques that we can use for solving the problems. One of the techniques are pseudocoding and flowcharts. We'll be understanding these techniques more in detail in today's session. In order to gain the in-depth experience of these techniques, we'll be going through the various problems and their solutions that we call exercises in today's session. Let us start with the very first understanding on what is a problem first of all. Problems are at the center of what many people do at work every day. Whether you're solving a problem for a client or maybe it's your day-to-day problem. The problem you face can be large or small, simple or complex, and easy or difficult. A fundamental part of every employee's or professional's role is to find ways to solve the problems. So being a confident problem solver is really important to your success. So here, the problems that we are talking about are mostly connected with the problem statements which are provided during the programming courses or the coding courses, which involves coding, to be specific. So here, in order to solve those problem statements, you need to have certain perspectives, you need to have certain analogy to find the exact solution. So what exactly is problem solving? So the process of finding the solution, there can be one solution or multiple solutions to difficult or complex issues. So here, the process which we'll be using for finding the solution is basically called problem solving. So how exactly we define problem solving? Let us understand more in detail. So here, when we talk about problem solving, we need to understand the problem statement carefully. So let us say if we are asked to find some prime numbers, we need to analyze and diagnose exactly what we are asked. We need to understand exactly how the output looks like, what exactly are prime numbers. We need to understand the domain knowledge. We need to come up with an algorithm that will help us achieve the desired results. So we have to collect and analyze the information and the data about the problem statement. If we are missing the domain information, let us say if we don't know about any specific task that we are provided with, let us say if there is a basic example of, let's say, finding the prime numbers, and if you're not aware of prime numbers, we must understand what a prime number is. Similarly, if we talk about the high-end programming, let us say if we are asked to find the defaulters from the you can say credit risk analysis. So in that case, we are supposed to understand what are the different terminologies which are used in the credit domain. So once we understand the problems and the domain, we have to look at the possible solutions which we can provide for the given problem statement, and we have to come up with an algorithm. So here, in order to come up with an algorithm, we need to understand the techniques here that we'll be doing in a while here. Once we are done with applying the algorithm, we need to verify whether the generated solution is exactly as per the expected one. Let us look at a few of the strategies that we can use to draw insights from the problem statements that we are given. So whenever we are provided with any problem statement or a question in programming or a coding, so we have to thoroughly analyze the question. All right, so we need to understand, like, what do I know about the problem, what is the information that I have to process, what does the solution looks like, what sort of special cases exist, and how will I recognize that I have found the solution. Now these are the questions which are generally should be taken into account by a learner whenever he is beginning with any problem solving. So let us say if we are asked to let's say find the sum of all the numbers between 1 and 20. So in this case the input would be the numbers. All right, so let us understand exactly how we can describe a problem, and how we can deeply understand the problem statement. So there are a few strategies that we can follow to understand about the problem statement. So whenever you are provided with any problem statement, you are supposed to ask these questions to yourself. All right, so what do I know about the problem? What is the information that I have to process in order to find the solution? What does the solution looks like? What sort of special cases exist? How will I recognize that I have found the solution? So these are some of the questions which will help you better understand the problem statement. Let's take an example here. So let us say we are supposed to find the sum of first 5 numbers. Alright, so let us suppose this is a question, or this is the problem statement. So the first question is, what do I know about the problem? So the understanding from this question is that it is a numerical problem, and here the input will be integers or the numbers, as well as the output will be the number only. So what is the information that I have to process in order to find the solution? So it says that find the sum of first 5 numbers. So here the information that we are supposed to process is 1, 2, 3, 4 and 5. What does the solution looks like? And it says sum. So the solution should look like 1 plus 2 plus 3 plus 4 plus 5, and that should come to 15. This is how the solution should look like. What sort of special cases exist? So there can be various cases. Let us say, what if there are alphabets if in case? What if there is a negative number? What if there is a 0? So these are some special cases. How will I recognize that I have found the solution? Well, for this there are some test cases which you can follow. For example, if the input is 1, 2 and 3, the output is supposed to look like 6, and just check if your output is matching with the expected test case. So if the test case is like 1, 2, 3, 4 and 5, the expected output is 15. So just check whether the test case output is matching with your output. So if it is matching, that means you have found the exact solution to that problem. It looks like we have clearly understood the strategies that can be used to understand the problem statement. But understanding the problem statement is not sufficient enough. We need to devise an algorithm for finding the solution. Now you must be wondering exactly what exactly is an algorithm. So an algorithm can be defined as a step-by-step procedure for solving of problems in terms of the actions to be executed in a given order. So an algorithm is nothing, but it is merely the sequence of steps taken to solve a problem. So here Let us understand how we can construct an algorithm using the various techniques in problem solving. The very first technique here we are talking about is pseudocoding. Well, pseudocoding is one of the easiest way of constructing an algorithm. You can define a pseudocode as a mixture of English and formatting to make the steps in an algorithm explicitly. So, what is pseudocoding? It's a text-based detail for designing the algorithm. So, let us understand with an example how a pseudocode looks like. Make sure that before we construct or write the pseudocode instructions, you should have a problem statement with you. So let me give you a very basic example of how a pseudocode looks like. So the very first problem statement that we are solving here is the easier one. So we have to write a pseudocode, to determine if the student has passed the exam or not. So how can we solve this problem statement using pseudocode? So as mentioned earlier, it is a mixture of English statements along with some formatting, some keywords. So this is how it is supposed to look like. So if student's grade is greater than or equals to 60, let us suppose we want to display the message on the computer screen. So we will write print passed. If this given criteria is not satisfied, then we'll use another term here called else. You can compare else with otherwise. Otherwise, we want to display a message on the computer screen saying failed. And that's it. That's how easy it was. So here, this is how a pseudocode looks like. So pseudocode is nothing but it is a mixture of some keywords like if and else and some English formatting to construct an algorithm. It is one of the easiest way of understanding how to solve a problem with the given steps. Let us understand one more example on writing pseudocoding here. So let us suppose the second question is, let's try one more example on understanding pseudocoding. I'm very much sure this will increase your confidence on writing the pseudocoding. Well, this involves a new concept here called loop. So let me explain you how it is constructed. So first of all, let us understand the problem statement. So here in this problem statement, we are supposed to ask the user to enter grades of 10 students. Now, before I complete the question here, please mark that here this task is repetitive in nature. Enter the grades of 10 students. If there is any task which is repetitive in nature, the solution to do that task, to solve that task, is to use a loop. I will be explaining you what loop is. Let us complete the remaining part of the question here. And it says find the average. So here, this is the objective. We are supposed to find the average. So here, we are supposed to ask the user to enter grades of 10 students and then find the average. Now, did you observe there is some hidden information which is missing here? And that is, to find the average, we have to find the sum of grades. Alright, so here there are a few things which are involved. One, there is a task which is repetitive in nature. The solution is to use a loop. The question says that we have to find the average. This is the objective. And there is a hidden subtask here, which is basically a dependent task for finding the average, that is finding the sum of the grades or sum of all the grades. So here, how do we solve such questions using pseudocode? For this, we have to construct a loop. A loop is nothing but it is a circular execution. Well, we have to write the algorithm to construct an execution which executes 10 times. How do we do that? So let us divide the problem and solve it one by one. This is called divide and conquer approach. In divide and conquer approach, we divide the problems into various subproblems. So before we solve the complete task, let us divide the task into various small subsets and let us solve this. So here, first of all, we will construct a loop. Okay, so here we will say set counter to 1. Now what exactly this means? This means that we have a number called counter. You can think of this expression, a counter with 1. Here I'm using a keyword called while. While counter is less than or equal to 10. Well, while is a keyword that we use for representing a loop. And this is how we create a block. So this while keyword represents a loop. So it says while set counter to 1. It means we have set the counter to 1 and we are saying that this block will keep on executing in a circular fashion till the time the counter is less than or equals to 10. Well, in order to meet this condition, we have to increment the counter as well. So for this, we'll write add 1 to the counter. So here, this is how the construction of a loop looks like. So set counter to 1 while the counter is less than or equal to 10. Enter the block, add 1 to the counter, and while. So this keeps on executing in a circular fashion. So this counter is going to look like 1, and then it says add 1 to the counter. It means 2, 3, 4, 5. Every time before we enter into the block, this condition will be checked while the counter is less than or equal to 10. So it is true, 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 and false. Whenever counter reaches the value of 11, this condition will be false and this circular execution will stop working. So these are the three ingredients of constructing a loop here. initialization, a termination, and the increment. Now the strategy is to enter the task here, or write the task here within the block so that it repeats every time. So here, let me just erase this. So here we will input the task here, and the task is ask user to enter grade. So you can see here that this star represents the task because of the space constraint. I'm just writing the statement here, assuming that this particular statement is within this block. So because of the loop nature, this statement will be repeated 10 times. Hence, we will end up asking the user to enter the grade 10 times. But what about the average? For finding the average, we have to find the sum. So here, for storing sum, we will create another storage called set grade sum to 0. Here we have come up with a new container called grade sum. So this grade sum is responsible for storing the sum of all the grades. So here we are adding one more step, and we are saying add grade sum, or we can say set grade sum equals to grade sum plus grade. Now what does it mean exactly? It means that whatever the grade has been entered by the user along with the previous grade sum should be updated with the new grade sum. So fetching the old sum plus the new grade, updating the grade sum. So this is how we will end up with finding the sum of all the grades. Remember, this block is also within the loop. So this sum will be calculated every time the user is entering the number or the grade. Now here, finally, we are supposed to find the average, and finding the average is super easy. To find the average, divide grade sum by 10, and we'll simply say print average, and that's it. And this demonstration closes here. So in this demonstration, we observe the various components of a problem statement. We observe that there are some subtasks, there are some hidden tasks, there is some dependency. We understood the repetition, and the solution to solve the repeated task is to use a loop here. So the construction of loop was explained using the while loop here, and the statements that we used here for finding the average. So I hope this clearly explains you how we can use pseudocoding for writing the algorithm to solve a given problem statement. Let us look at a very bigger example on preparing a recipe here. So it is called a hollandaise sauce. So this is basically an example which is basically trying to give you more understanding of how to write the pseudocoding contextually. All right, so previously it was technical, so this time we are talking in a very easier manner. so that it gives you a confidence of how to write the pseudocodes. So here, in order to prepare this sauce, we have some ingredients here which are mentioned, and this is a very basic English statement which is used here. So it says like heat butter until bubbling, combine all the other ingredients in blender. With blender turned on, pour butter into yolk mixture in slow stream, and then so on, and then makes about 1 to 1/4 cups of sauces. So this is a English statement here which is being used for writing a recipe for preparing a sauce. Now let us understand how we can write the same approach for preparing a recipe in a technical way using pseudocoding. And with this example, we will try to understand what are the various keywords which are being used here for writing the pseudocode. So the observation should be on the approach as well as on the keywords which are being used here. So let us look at this example here. So this is an algorithm for preparing the same sauce here. So here we are using some keywords like if. So if concerned about cholesterol, so put butter substitute in a pot. Otherwise, so here we are using other keyword called else, put butter in a pot. So you can see here how we can do the decision making in pseudocoding. All right, so this is this thing can be represented by decision making. All right, so let us understand how to make the decisions in pseudocode using the keyword like if and else, and there is a condition here. All right, so this is a condition. Now there are some some preparations like turn on the burner, put pot on the burner, while not bubbling, leave pot on the burner. So there are two things that you're supposed to observe here. The very first thing is that while. If you observe while, this is basically a loop. All right, this is a loop. So, and every loop requires a condition like if else. So while not bubbling, so till the time it doesn't starts bubbling, this statement will be repeated every time. So what does it means? Leave pot on the burner. So it means that the pot will remain on the burner every time this execution is running circularly. So as and when it starts bubbling, this condition will become false, and we will move to the next statement then. Right? Otherwise, we will not move to the next statement. So the second point that I want to highlight here is basically this gap which is provided here. Now this gap is basically called indent. So indent is basically specific to the Python programming language, but let us understand in another way. So indent here is representing the block. A block basically represents the coding block which will be repeated every time as till the time the condition here is true. Now why this particular statement is not repeated? And the reason is because it is not following the same indent. If you observe here, so this is starting from the beginning. So this is the block which will be repeated till the time the condition is not false. So it looks like this while, and the condition here. So I will write some code here. So this is the code, and there is some more code here. So what I'm trying to say is that this is the coding statements which will be repeated every time, and this will not be repeated because it is outside the block. Look at the indent. All right. Okay. So once once it is bubbling, put other ingredients in the blender, turn on the blender, while again one more loop here, while more in pot. It means that till the time there is some content in the pot, keep on pouring the contents into the blender in slow steam. So this line will keep on executing till the time this condition is not false. So it means that till the time it is empty, not empty, keep pouring it. All right. Once it is empty, turn off the blender, and that's where the pseudocode ends. So in this example, the focus was on understanding how to write the pseudocode, as well as what are the various keywords which are being used here for expressing the steps, all right, that we want to follow. All right, so this is a step-by-step process to solve a problem. So any learner who is looking forward for a program on, let's say, data science or any software development or any computer science domain, generally it will require you to write the coding, and before you write the code, it is a must to know how to solve problems. And in order to improve and work on your problem solving abilities, you can use the techniques such as pseudocoding to get an in-depth understanding of how to understand the problem, as well as how to write the step-by-step solutions, right, to step-by-step process to solve a particular solution. So I hope you have understood what pseudocodes are and how to write the pseudocodes. Let us have a closer look at the while loops in pseudocoding in order to bring more clarity on this concept. So here we are coming up with one more example. So in this example, we have repeating a series of statements here. So it says that set count to 1 while count less than 10, write enter integer number, read a number, write enter a number, set count to count plus 1. Well, this is basically a validation of whether you have understood the while loops clearly or not, as per the previous example. So if you know how many values were read in this particular example, please let us know by commenting down at the comment section below. So we are looking for your responses on this particular task. All right. Now let us talk about another approach of solving a problem which is more precise and which is more, you can say, expression oriented and more mathematical, and which is more clear as well. So here this is the other approach of constructing an algorithm for solving a given problem statement, and this is called flowchart. Flowchart is one of the amazing ways of constructing the step-by-step phases to solve a problem using some pictorial representations. So it is a means of visually presenting the flow of control through an information processing system, the operations performed within the system, and the sequence in which they are performed. It means that here we will construct a step-by-step workflow to solve the problems. Yes, it is graphical, so it is going to require you to understand some pictorial representations and their purposes. So first of all, let us understand some of the diagrams which we use for representing various steps. So here you can see this box here. This represents the start or end of a program. Generally it has to be of an oval shaped like this. All right, and okay, there was an error here, so this is a correction. So it has to be a oval shaped picture. It represents the start or end of a program. So it looks like this: start and simply end. This is how it looks like. Then we have this rectangle here, which represents a computational step or processing function of a program. Now what does it mean? It means that if there is some processing happening in your code, in an algorithm, you are going to write that processing within the this rectangular box. For example, let's say boil. For example, let's say heat. For example, let's say add 1. For example, let's say add a into B. Look at that, all right? So here we are writing a processing component in a rectangular box. Now here, this is the input expression, all right? So if in your program or if in your problem statement, it requires you to read an input from the user, all right? So I can give you a context of, let's say, keyboard, all right? So if the program says that you have to ask the user to enter something via keyboard, you are supposed to use this input expression. Let me give an example. Let's say accept age. Let us say accept salary. Let us say read grade. So you can use any term. You can say accept, you can say read. So here the context is whether age, salary, or grade. So here we're using the input expression, the input diagram there. All right. So here we will assume that the user is going to enter some input via keyboard. And please make sure that when constructing the algorithm, we are never ever concerned with what the data is. All right. We are concerned about where the data is and what the data is. So for example, let's say if I say read grade, it doesn't really matters, and you're not supposed to figure out that what exactly a grade he has entered, whether it is 15 or 16 or 20 or 25. Do not look for the specific value. You are supposed to go by the context, not by the value. All right. So that is the input expression. All right. Now the output expression slightly differs, and the output expression looks like this. All right. So this is how the output expression looks like. So how we can display, how we can use this output expression. So we can use this output expression this way. So let's say we can say print average. We can say, let's say we can say print score. We can say, let's say print interest rate. All right, like this. So this is how we print the output. Then this is for decision making, and this is one of the important aspect. So this is similar to if and else in pseudocode. So this diagram is for decision making. How to use this? Let me give an example here. Let's say is age greater than equals to 18. So there can be two aspects to it. So either the age can be greater or equals to 18, or it can be lesser than 18. So there are two branches to this diagram. So it can be either yes or no. You can also say either true or false. So you have to take the respective decision. So I'll say, let's say print valid for voting if the age is greater than or equals to 18. Or here I will say, let us say print not valid for voting. Okay, so this is a very basic example of how we use this decision making box for taking the decisions. I hope you have clearly understood how to use this diagrams. So once again, a quick revision. This is a start or end of a program. This is a processing box. This is for taking the input, and the output looks like this, and this is for making the decisions. Let us try to understand how a flowchart can be used to solve a problem statement by using the given flowchart here. And this flowchart basically utilizes almost all the pictorial representations that we went through in the previous slide. So first of all, let us go through the question statement, and it says that this is the flowchart to find the largest of two numbers. So here, this is the algorithm, step-by-step algorithm to find that which is the largest number from the given two numbers. So here it says that start read A and B. So here A and B are basically the containers or the solutions that we are using here for storing the data. All right, so there can be any value inside A and B. So here you can visualize this as A and you can visualize this as B, and here we are reading the input from the user via keyboard, you can say. We are not concerned with what data exactly within this containers is. All right, what we are concerned with, where is the data, and the first number is in A and the second number is within B. Now here we are using this pictorial representation for finding the expression, right? The expression which will evaluate which one is a greater. So is A greater than B? So you don't have to think in a positive way that it should be greater. As a programmer or as a problem solver, you are supposed to provide the solution for both the aspects. You are supposed to provide the solution for true, you are supposed to provide the solution for false, both. So what will happen if the A is greater than B? So in such cases, it is going to print A. What happens if the A is not greater than B? So in such case, it is going to print B. And every time whatever it prints, it is going to terminate. So let us do a dry run to evaluate this algorithm, whether it is working on the expected test cases or not. Let us say, if we say that the input is 4 and 7, the expected output is 7. Let's try. Read A and B. So here A is 4 and B is 7. Is 4 greater than 7? No. It prints B, that is 7, and then it terminates. So here the output is exactly as per the expectation. So this clears us that this flowchart is working as expected. And this flowchart, we were using start, input box for reading the data, the decision making box for making the decisions with the two branches here, yes and no. And here we are terminating. So I hope you are able to clearly understand how this flowchart is working and how we are using flowchart to solve a given problem statement in a step-by-step manner. Let us look at another example on understanding how flowchart works. So here we have come up with a new problem statement here. So in this problem statement, we are trying to find the largest of the three numbers which are entered by the user. So here it is A, B, and C. Let us see exactly how this flowchart is working. So start, read the three numbers, that is A, B, and C. We never know exactly what these numbers are, and we are not concerned about that. All right, we'll just write the algorithm which will always end up with providing us with the largest of the three number. So here we'll check if A is greater than B. So here it means that is A greater than B? Yes, means A is greater than B and B is smaller. Now we'll come here, we'll check once again, is A greater than C? If it says yes, then A was already greater than B and now it is already greater than C. That means A is the greatest one. If A is not greater than C, that means C is greater than A and A was greater than B. That it automatically turns out that the C is greater than all. Let us check here. Is A greater than B? No. That means B is the greater one. We only need to take care of C now. Is B greater than C? Yes, in that case print B, otherwise print C. So this is how exactly the algorithm is constructed. Let us do a dry run in order to understand whether this problem statement is working on expected grounds or not. So let us construct a test case here, and let us assume that the inputs are 7, 9 and 4, A, B and C. Is A greater than B? No. 7 greater than B, that is 9. So 7 is not greater than 9? No. Is B greater than C? Is 9 greater than, that was 4? So here it is yes. Print B, it ends up with 9. So here the output is as expected. So that means that this particular flowchart is working as per the expected output. So here this was another example on understanding how we can use flowcharts to construct or write an algorithm to solve a given problem statement. Well, this was on decision making. What about loops? So in the next demonstration, we will understand how loops are constructed in flowchart. So this is one of the example where we are using loop in a flowchart to find the sum of first 15 natural numbers. Now this is how exactly a flowchart looks like. But let us understand exactly how this is working. Well, it feels like there is a circular execution here. So it confirms that there is a loop. Now how do I determine that this is a loop? It will be clear once we start executing the flowchart. In order to understand the flowchart, we have to visualize it this way. So here we are finding a sum. So we have created a variable here in the processing box called sum equals to 0 to contain the sum. Now here we have a variable n. N is basically a counter, as well as this n will also work as an input as well. Well, this is an increment to n. This is a processing or the logic to find sum, and this is basically the termination condition, and here we are printing the output. Well, this time I'm using a different box here, so it's okay, but the output box exactly looks like this. Looks like there are various ways to display the output. Now that was just an identification that I've provided you, like what step is what. A counter, a tracker, as well as input, increment, processing, termination, output. So that was just an identification. Let us understand exactly how it is working. So in order to understand the working of this flowchart to find the sum, we'll visualize it this way. So here we have a variable with an initial value of sum. Did you observe that I use a term called variable? A variable is nothing but a container which is used to store some data. So that's how we visualize a variable. There is one more variable here called n, and there is some initial value to it, and that is 0. We have to follow the sequence. So sum is 0, n is 0. Then the next step says n equals to n plus 1. Always remember, in programming or in coding, the expression is always evaluated from right to left. So n is 0, 0 plus 1 is 1, the n is updated to 1. So here I have come up with a new value of n called 1. Now let us move to the next step. It says sum plus n. Now if you look at the data here, the sum is 0 and the n is 1. So it will be 0 plus 1 and the sum will be updated to 1. We'll follow the sequence here. We'll check the condition. Is n equals to 50? So it is no. N is 1. We will increment the n. N is 1 plus 1 updates the n, which is 1 plus 1, 2. Now we'll move to the next step here. Sum, which is 1, plus n, which is 2, 1 plus 2. This gives us the sum as 3. We'll follow the sequence here. Is n 50? No, n is 2. We will increment the n. Now observe the circular execution here. This is called a loop. So n equals to n plus 1, which is 2 plus 1, gives us 3. We'll move to the next step here. This says sum, which is 3 plus 3, gives us 6. Is n 50? No. So we'll increment n to 4, and this gives us 6 plus 4, 10. And is n 50? No, it is 4. We'll increment n, which is 5, and we'll say 10 plus 5, which is 15. Now this will keep on happening till the time n becomes 50, and here we will end up with a sum of all the numbers. So once n becomes 50, it will print the value of the sum variable, and then it will terminate. So this is how we construct a loop in flowcharts, and it was a very beautiful example on understanding the various expressions such as decision making, looping, variable initialization, summing, and increments and everything. So I hope you have clearly understood how the flowchart are used in problem solving for constructing the algorithm in a step-by-step manner. The difference between the flowchart and the pseudocode is pseudocode uses the English plus mix of some keywords formatting, such as if, else, while, like keywords. Whereas flowchart is more precise towards expression. It doesn't uses English statements much. It uses the mathematical expressions more to represent a given step, whether it is input, whether it is processing, output, decision making. So everything is expressed in a technical manner, I would say. So I hope you have understood the flowcharts clearly. So that was all for today's session on problem solvings and the various approaches that you can use for solving the problem statements. We discussed the pseudocodes and the flowcharts in detail. I hope you have understood them clearly. I recommend to start with writing pseudocode statements initially and then gradually move on to the flowcharts for better understanding of how to construct the algorithm in a step-by-step manner for solving the given problem statements. Now with this video, I am sure that this will improvise your problem solving abilities and will give you a new perspective on how to approach a problem to find its solution. So that's all for today's session, guys. Thank you for watching the video till here, everyone. So if you have liked the video, please make sure you don't forget to hit the like button, subscribe to the channel, and press the bell icon for updates. Thank you, everyone. Take care.